So what we're going to be looking at now is that we're going to be moving on to the next section, which deals with roots and radicals and how to find like square roots, cube roots, fourth roots, and all that stuff, and dealing with the square root sign um, and radical expressions, solving them, looking at their graphs, etc. So we're going to start off with just kind of the basics. So if you have a number, which we'll call the base, which is the a here, so this would be called your base. The base to some number. Okay. If the base is a positive number, all right, then you're going to have some sort of roots. If it's 0, then you're going to have one root, and if it's a negative, you're not going to have any roots. If it's even, if the power you're taking it to is an even power, or the root you're taking it. So by thinking about this, if you have the square root of 8, okay? The square root of 8 is it's even and it's positive. So that means we have two answers. We have plus or minus 8, or plus or minus the square root of 8. But what we can do now is that we can take it and we can go, okay, how about the third root? What's the third root of 8? Well, that is 2. You can also take the third root of negative 8, which is negative 2. Whenever you have odd numbers, what happens is that you only have one solution, because if you multiply a number an odd number of times, the sign stays the same. A negative 1 times a negative 1 times a negative 1 is a negative 1. If you multiply it by an even number, negative 1 times negative 1, it becomes positive. Okay. And the other thing that we have is negative numbers underneath the radical. So like negative square root, we don't have any real answers, or we don't have any real roots if it's even. Alright, so the parts of these radicals that we're dealing with, the number on the outside, which is how many roots you like, the root that you're taking it to, n is called the index. Alright, and then the number underneath inside the radical is called the radicand, and and that's the number that you're going to be breaking down and trying to find how many groups of whatever the number is that you want to find. Okay. All right, so looking at this simplifying, so if we want to break down 27, all right, 27 can be broken down into, so since it's negative and it's an odd number, if it breaks up into a nice single number, it's going to be negative. So if we break up 27, that would be 3 and 9, and then 3 and 3. Okay. So as you see, since we want a cube root, we need 3 of a kind to come out. So that would be a negative 3. Negative 3 times negative 3 times negative 3 is a negative 27. Right. Now if you look at the next one, square root of a negative 169, well, the square root of 169 is 13, but since it's negative, and since we're taking the square root, there is no number that works. And what we've talked about previously has been, oh, well, it'd be imaginary. It'd be 13i. In this chapter, we're not going to be dealing with imaginary numbers. We only want to stick with real numbers. So if you ever get something like this, you would just say there's no real numbers. Okay. So again, we're not going to be dealing with imaginary numbers in this section. So simplifying. So now if you're taking a root to a positive and then you take and then you're simplifying a variable, you're going to want to do a absolute value for it. This isn't a huge deal, but it is something that you want to make sure that it's always positive. So if we want to take the square root of, let's say, y to the fourth, okay, well, that's y squared, and we're taking the absolute value of y. But if we were taking the cube root of y6, we would just say y squared. Okay. Since this is an odd number, okay, we don't need the absolute. And since the other one is an even number, we need the absolute value. Okay. It's not a huge deal. It's just something that we want to make sure that we keep our variables positive, and that's why we do that. So again, you can't have a negative underneath the radical. Now, simplifying. So if you get something like this, where you have the cube root of x to the fifth y squared z to the fourth, what you're going to want to do is you want to break it up. Well, like x to the fifth can be written out as x times x times x times x times x. Okay, 5 x's in a row. Y squared can be written out as 5y's, or 2y's, and then 4z's can be written out. Now, this number on the outside, this 3, that's how many we want in a group to come out. Okay, and however many groups come out, that would be the power. So if we look here, we've got 3 x's, and that jumps out front, and we've got 3 z's, and those get dropped out front. Everything else that's left underneath stays. You need, in this case, you need a 3 of a kind. Now for a fourth root, you would need 4 of a kind. For a square root, you just need pairs, however many pairs, couples go out, singles stay home. But if you take it to a higher root, you got to take the larger groups out. Okay, and those, whatever groups come out, however many groups you come out, you put those out front, and everything else stays inside. Okay, so looking at these simplifying. So we're taking the square root of 4 x squared y 4. So we break it up. Square root of 4 is 2. Okay, so we're going to have a 2. And now we look at the power or the variables underneath the radical. We have x times y times y times y times y. Now the question is, how many pairs do we have? Well, we've got a pair of x's, so those come out, and we've got 2 pairs of y's, so that would be y squared. And this is your answer. That is the root of it. And since it is positive, we would take the absolute value of it. Okay, but that would be your answer. So now you look at the next one. You would want the cube root of negative 64, where 64 breaks up to 8 and 8, which breaks up to 4, 2, 2, 2, 4, 2, 2, 2. So it looks like we've got 2 pairs of 2's. So that means out front we would have 2 times 2, and it would be negative because the inside's negative. And then we would look at the 6's. 1, 2, 3, 4, 5, 6 C's. How many groups of 3 can we make? 2. So it would be c squared. So it looks like it's a negative 4 c squared would be our answer. Okay. So again, whenever you're simplifying, you're going to want to break it up into its parts and then try to find its groups. So now here would be an application of what you would see, dealing with a lot of formulas and different things. So we've got a sphere, and we want to find the volume of it. So, like a ball, like a baseball. And we know that the volume of it is about 10 cubic inches. And we want to find the radius of it. So this right here is our volume. So that's our V. So we're going to go 10 is equal to 4/3 pi r cubed. And now we want to get r by itself. So we're going to get the r cubed by itself. So what we'll do, we'll multiply both sides, or divide both sides, by 4/3 pi and 4/3 pi. That gets us r cubed is equal to, looks like it's going to be about a 30 pi over 4. And then we would take the cube root of it. Okay. Since we're having something to the 3rd power, we'd want to take the 3rd root of it. All right. And by using that, we get approximately, we would estimate our number to about 1.34 inches. Okay, so our radius for this sphere would be about 1.34 inches. All right, here's your IRAT. So your IRAT, the first 2 simplify, so break it down. The first one's just a square root, the next one's a 4th root. And then the last one, you have to find the radius given the area. So again, you plug this area in there's this area of a circle formula. Plug that 32 pi there, and then solve for r. All right. So there's your IRAT. You can get those 2 done. Simplify the first 2, and then solve for r.